A problem or a numerical on DC motors. Numerical on DC motors. Let me read out the numerical for you. A series motor takes 20 amps at 400 volts, runs at 250 rpm. The armature and field resistances are 0.6 ohms and 0.4 ohms respectively. Find the applied voltage if the current to run the motor at 350 rpm. If the torque required varies as square of the speed. Torque required varies as the square of the speed. So let us write down the values given. They have given data 20 amps I1, V1 is 400 volts, RA 0.6 ohms, field resistance is 0.4 ohms, N1 is 250 rpm, similarly N2 350 rpm. Find V2 is question mark, I2 is question mark. Condition given is T is directly proportional to N square. So we know that T is directly proportional to phi into Ia. Now from this what will happen? Phi is also directly proportional to Ia. So what we can write? T is directly proportional to Ia square. From this we can say that Ia2 by Ia1 is equal to K into N2 by N1. So cross multiplying Ia2 is equal to Ia1 into N2 by N1. So Ia1 is 20, N2 is 350, N1 is 250. So we get Ia2 is equal to 28 amps. You can check the Ia2 value. Now we know that in a series resistance, so this is your back EMF EB, this is your R1 or R, so this is your I, this is your R field. So here it is plus minus back EMF and resistance RA. From this we can write V is equal to IRF minus IRA minus EB is equal to 0. So voltage is across here V. So from this we can simply write EB is equal to V minus I into RF plus RA because it is a series resistance. So substituting we will get EB1 as 380 volts. Similarly, substituting the value for EB2 is equal to V2 minus 28. So we know that back EMF EB is equal to P5 NZ by 60A. Keeping this formula, we can say that E1 by E2 is equal to Ia1 N1 by Ia2 N2. So E1 is 380 by E2 is equal to 20 into 250, 28 into 350. So substituting this we get E2 as 744.8 volts. Now from this we will be able to find out the value of V2. So we know that EB2 is equal to V2 minus 28. Substitute the values. So you get V2 as 772.8 volts. So this is how to solve the problem on DC series motor. Thank you.